Today we're going to look at another way to solve quadratic equations. Today we're going to look at how to factor to solve. The new vocabulary that we're looking at in this section is factored form and the FOIL method. Here's a key concept about the FOIL method for multiplying binomials. Pause the video and take a second to write this down. It is very important that you write this down. If you notice that we're using colors here, you might want to use different colors to help color code your notes. So let's take a look at an example here. This question asks us to write a quadratic equation in standard form with -3 and -2 as its roots. So -3 and -2 are the solutions. So if we look at this equation right here, we have in parentheses x minus p times x minus q equals 0. So x minus p is a 0 and x minus q is a 0. So we're going to take our roots, -3 and -2, and we're going to plug them into our equation. They can be our p and our q. Okay, so let's do that. We have x minus a -3 and times x minus a -2 equals 0. We have x plus 3, x plus 2. So I want you to notice something really quickly. When we had that the roots were negative, the zeros, the way we write the zeros is the opposite. So if they're negative, we're going to end up adding them in our zeros, and you'll understand why in a minute. But say if they were positive, this was a positive 2, then if you were plugging it in for q, it would just be x minus a positive 2, so it would just be subtraction. So just store that in the back of your mind for a second. Okay, so we've simplified as much as we can, and now we're going to bring in the FOIL method. So FOIL stands for first, outer, inner, and last. So we've got first, outer, inner, and last. Okay, so what we're doing, if you notice, when we have parentheses that are up against each other, that's called multiplication. So we're going to be using the distributive property, but with binomials instead of monomials. Okay, so we're going to do the first term. So the first of each is x times x. So we have x times x. Then we have plus outer, so the outer parts of our side. So we've got x times 2, x times 2, and then we have inner, the inner terms. We've got 3 times x plus 3 times x, and then our last terms. So we've got the last of both is 3 times 2 plus 3 times 2. Don't forget to bring down your equals 0 because we haven't touched that yet. So when we have x times x, we get x squared. We get 2, or x times 2, we can just write that as 2x, right? Then we have plus 3x plus 3 times 2 is 6 equals 0. So if we look in here, are there any terms that are like terms and that we can combine them? So here we have 2x's and here we have 3x's, so we can combine those. So we would get x squared plus 5x's, 2x's plus 3x's, plus 6 equals 0. And we're done, because the question only asked us to write a quadratic equation in standard form. So it's our ax squared plus bx plus c equals 0. And it has the roots of -3 and -2. So now we're going to get into actually solving the equations by factoring. So we're going to use this key concept called the zero product property, which in words says for any real numbers, a and b, if a times b equals 0, then either A has to equal 0, B has to equal 0, or both A and B equal 0. If you just think about that for a second and see if that actually makes sense in your mind. Okay, so we have an example of this. If we have the term x plus 3 times the term x minus 5 equals 0, then we know that x plus 3 equals 0 or x minus 5 equals 0. Okay? So just like in the previous example, I said that these are our zeros or our roots, right? So we have that our zeros, we're going to set them equal to 0 to find out what our roots are. But if you notice that we have an example like this where 16x squared plus 8x equals 0, we don't have that these terms right here are being multiplied together. We have that they're being added. So it doesn't follow the zero product property. So we can't just set this term equal to 0 or this term equal to 0 because it's not multiplication that's happening. So what we need to do is factor. We're going to learn how to factor so that we can set our terms equal to 0 because our terms are being multiplied together. So let's look at this example right here. So when for factoring, we want to find the greatest common factor of both of these terms right here. Okay? So I'm going to look in and I'm going to see, okay, they both have x's. Okay, so I know that that's a factor. And 8 goes into 8 and 16 goes into 8. So I would say that the greatest common factor is 8x. So I'm going to pull an 8x out of our equation here. So let's go ahead and do that over to the side. So if I'm pulling out an 8x, pull the 8x out, and I will ask myself, what times 8x gives me 16x squared? So you can put this into different pieces. You can put it into a numbers piece and into variables. So if I'm looking at the numbers, what times 8 gives me 16? The answer is 2. And the variables, what times x gives me x squared? And x times x gives you x squared because you have two x's, right? So then I will ask myself, what times 8x gives me 8x? If you get the same thing, you must be multiplying by 1. Okay? So just to double check to make sure that we did our factoring correctly, which is always super important, let's go the opposite direction. If we were to redistribute this back out and see what we get, we have an 8x times 2x. 8 times 2 gives me 16. X times x gives me x squared. Beautiful, our first term is correct. And then 8x plus 1 gives me 8x. Awesome, also beautiful. So we know that our factoring is done correctly. So I want you to take a look at this equation right here and see if it works now for the zero product property. Do we have two terms that are being multiplied together that we can set equal to 0? So let's take a look. We have this term, and it's being multiplied by this whole term. We don't have any stragglers. We're not adding or subtracting anything else outside of those terms. So yes, we've got one term and another term that are being multiplied together. So now we can use the zero product property. So we're going to take one of our terms, which is the 8x, and set that equal to 0. Or we're going to have our other term, 2x plus 1, and setting that equal to 0. Okay, so now we have two problems that we're just going to solve for x for. So let's start on the left. We divide by 8. Left with x equals 0 divided by 8 is always 0. Or, okay, we're going to do our other problem. Solve for x. So we subtract 1. 2x equals negative 1. Divide by 2, and you're left with x equals negative 1/2. Okay, so here are our zeros, or our roots, or our solutions. We have x equals 0 and x equals negative 1/2. So if we're going to write this in our set notation, doing this here at the top because I ran out of room at the bottom, we have a set of x's such that x equals 0, negative 1/2, end bracket. So if you notice in this problem, we have an equation that has, two terms. Okay, so we've got an x squared term and a 8x term, correct? So next, in our next example, we're going to do an equation that has 3 terms, and it's going to change a little bit the way that we are factoring. But the idea is still the same, that we want to get 2 things or 3 things or whatever it ends up being that are strictly being multiplied together to equal 0. Okay, so that's our goal, is to get 2 terms or 3 terms or however many that are all being multiplied, see they're being multiplied here, to equal 0. A special pattern is used when we're factoring trinomials. Trinomials meaning 3 terms, 1, 2, 3, tricycle, I don't know what else goes with try, but, so 3 terms, so we use a special pattern. Okay, so I want you to write this down. The first thing we do is we multiply the values for a and c. So we multiply a times c. Beautiful. Easy peasy lemon squeezy. Then we got number 2. We find 2 values, m and p, because we don't know them yet, such that their product equals a times c, and their sum equals b. Product goes with multiplication, sum goes with addition, correct? So this statement might be a little confusing right now, but we're going to do an example to go with this. A huge thing that is super-de-duper important when you're doing this is you need to stay organized. Okay? This can get kind of hairy, and you want to stay organized. So a really good way to do this is to make a table. Okay, so that's what we're going to do in the next one. Okay, so we're going to look at an example. We're going to take this expression, 6x squared plus 13x minus 5, and our first step is to multiply a and c. So what are a and c? A is 6 and c is negative 5. Okay, so we're going to multiply. We are multiplying. So 6 times negative 5 gives us a negative 30. So now we need to find 2 values. These are going to be the magic numbers, m and p, such that their product is negative 30. So when you multiply them together, it's negative 30. And when you add them together, we get 13. Okay? Those are our steps from above. So to break this down a little bit more, let's make a table. Okay, so we're looking for factors of negative 30. Let's start there. So factors would be 1 and negative 30, right? And 2, negative 15. 2 times negative 15 is negative 30. 3 times negative 10. 5 and negative 6. Then we also have negative 1 and 30. Negative 2, 15. Negative 3, 10. Negative 5, and 6. Okay, I think that's it. Yeah, that should be it. Okay, you got to be careful. When we have a negative, you know that one of the terms has to be negative and the other one has to be positive, because a negative times negative is a positive times a positive is also positive. So if you notice, we have the same numbers but just different signs in front of them, so that makes them different. Okay, that 1 is not negative 1, so that's why these are 2 separate entities. Okay, so now we want to find their sum. So let's go through. So if we have 1 plus negative 30, we get negative 29. That is clearly not 13. Okay, 2 and negative 15 is the sum of negative 13. Not positive 13, not quite. Okay, so you have 3 and negative 10 gives us negative 7. 5 and negative 6 add them together and get negative 1. Negative 1 plus 30 is a 29. Negative 2 plus 15 is 13. Oh, that's a good number. I like it, but let's finish them just to make sure. Okay, we've got negative 3 and 10 gives us 7. And negative 5 plus 6 gives us a 1. So we have found our magical combination here. Here's our magic combination. Because if we notice, our sum gives us B. That's what we wanted, right? And our A times C values here, yep, when you multiply them together you get negative 30. So this is our magical combination. Beautiful, right here. This is what we want. Okay, so now we can write our middle term. That 13x can be rewritten as a negative 2x from over here, right? Negative 2, and plus a 15x. Okay, so we're just kind of rewriting it in a different way. Plus 15x. Okay, so that's how we're going to rewrite. We're going to substitute. So just like when we were doing substitution, when we were solving for systems of equations, I am renaming 13x. We're renaming 13x negative 2x plus 15x. That is true too anyway. So we're going to, in this expression, we're going to plug this bad boy in for here. Okay, so let's rewrite, and we get 6x squared minus 2x plus 15x minus 5. Okay, so now we're going to group our terms. Okay, so we're going to group them like this and like this. It's another two different groups, but see, we're adding in the middle, so we're not quite done yet because we want to be multiplying. So I want to find what our greatest common factors are of each of these. Greatest common factors are of these. So let's take a look. I would say that our greatest common factor of this would be, there's a 2 in each of them, right? You can divide this by 2, so we got 2 in there. And there's an x in there, right? Okay, so if I pull that bad boy out, 2x times what gives me 6x squared? So 2 times 3 gives me 6, and x times x gives me x squared. And this is the same term, so we keep our subtraction sign 1, okay? Plus, then we're going to pull out our greatest common factor of 15x and 5. So I would say that that's a 5, right? So we've got 5. 5 times what gives me 15? 3. And bring the x, because we need that x in there. And 5 times 5 gives us, or 5 times 1 gives us 5. Yes, that's true. Okay, so if you notice something right here, whatever's in parentheses needs to be the same. They should be the same. 3x minus 1, 3x minus 1. Boom, we know we're doing something right. If these end up being the same, that's a beautiful thing. Okay, so now we're just going to rearrange these a little bit. Okay, so we're going to take this term, 2x, and this term, plus 5, and that's going to be one of our factors. So we get 2x plus 5 as a factor, and our other factor is 3x minus 1. Boom. Now they're being multiplied together, and that is our answer right here. Okay, I want you to check this on your own. So go back through and FOIL, use our FOIL method to check this. Make sure that this right here comes out to be this right here. And that is your homework, to FOIL this bad boy to see if we get the same thing. Okay, that's going to be what I'm checking for mañana in class. Okay, so we're going to practice this. I know that this was kind of crazy and all over the place, and it's quite a process. Lots of algebra going on here. And I just want to say it's super important that you keep organized and always have your end goal in mind. So know where you're trying to get at the end so that you know when to stop, because a lot of people might stop somewhere in the middle and think that they're done, or go too far, or find something that they're not actually looking for. So always keep asking yourself, what's my goal here? Where am I trying to go with this? So that you know when to stop. So in class, we're going to be practicing this a lot. This is going to take a lot of practice. This is just a skill that you just got to keep going until you see patterns and figure it out. So we're going to practice a lot. So be ready for this. There are also a lot of other ways that you can factor, a lot of other methods, and so maybe you potentially have learned a different way to factor, and as long as you get the same answer, I'm okay with that. So don't be, I hope you're not super confused by this way. Maybe this way actually helps you a little bit more, but we're going to practice this way, and feel free to practice other ways, but as long as you're getting the right answer and you're getting there in a good mathematical and logical way, then I'm totally okay with that.